Hello everyone, welcome to Chem Classes. I am Bani Chakravarti, a student of class 9. As a student, I know the difficulties faced by students in their studies. I feel a change we need in the Indian education system. So from today, I and you are going to change the world with our ideas. For making good ideas and good values, we have to educate ourselves in modern ways. So let us start from today to bring the dynamism and the modernization we want to see in this world. So without further delay, let us get into our topic. Our topic is work from the chapter Work and Energy of class 9. To get success in a field, we have to know the goal that we want to achieve. So let us get into our goal, which we are going to cover in this session. We will know about work, relationships between work, unit, and work done against gravity. So when is work said to be done? Work is said to be done. Think that a person, he does so much work. He reads, he writes, but according to science, that may include very less amount of work. But think that you are working with suppose a book, you are not studying. According to the normal human sense, you are not doing any work, you are just working with the book. But according to the physics, you are doing work. Now, how can we say that you are doing work or not? When a body, think that this is a body in a plane, is kept in a plane, and a force of F acts on it. When F force acts on the body to causes a displacement of s distance, and the body reaches here, then we can say that work is done. Work is done. Okay. Now what are the factors on which work depends? Work depends on two factors: the force acting on the body and the displacement caused by the force. What is the force acting on the body? Means think that if the force acting on the body decreases, the work done also decreases, and if the displacement decreases, then also the work would decrease. Means work is directly proportional to force and displacement. Now we will get to know the formula of work done. Work done equal to force into displacement. Now we will know the dimensions of work done. When think that we will define work in the terms of fundamental units. Dimension of work equal to dimension of work, dimension of this means what is the dimension of a force? Means how can we define force in terms of fundamental units? As we know, F equal to ma, mass, acceleration equal to v minus u by t, that is into s equal to m. Now we are going to discuss about the unit of work done. What is the unit of work done? Unit of work done. The unit of work done can be in CGS unit or SI unit. First, let us see the CGS unit. As we know, work equal to force into displacement. So unit of work equal to unit of force. We know what is the unit of force. Unit of force is Newton, and S means displacement. And what is the unit of displacement? The unit of displacement is meter. So the unit of work is Newton meter. Newton meter is also known as joule. This is the SI unit of work done. Now we will see the CGS unit. In CGS unit of force is dyne, and CGS unit of displacement is centimeter. Dyne centimeter, it is also known as erg. Now we will discuss when suppose a body is there and in which the force is acting at an angular component, then how is the work defined? Think that this is a body. From this side I am pulling it. I am putting the force in angular component and the displacement is occurring this side. Now how there are two components of force acting on the body, one in this side and one in this side. There are two components of work in this body, one in this side and one in this side. When it works in this side, the work done is Fs cos theta. It is Fs cos theta, and when it works in this side, it is Fs sin theta. As there is no displacement in this side, then Fs sin theta equal to 0 and Fs cos theta has a value. Think now, let us understand this with the help of a numerical. So we can see a force of 30 Newton acting on a body causes a displacement of 3 meter and the force acts in a direction of 90 degree. Let us draw the diagram of how this is the body and the force acts like this. The force is of 30 Newton and it causes a displacement of 3 meter. So let us see the work done. Work done equal to force into displacement into cos theta. What is the force? 30 Newton. What is the displacement? 3 meter, and the value of cos 90 is 0. So work done equal to 0 joule. This is also known as zero work. Means when a body acts, when a force of any value acts on a body at 90 degree, then the work done is 0 always. Now let us see what is called work done against gravity. As suppose this is a pen in my hand and I take it above the force of gravity. I am exerting some force which is against the gravitational force acting on the earth, and suppose this I am taking, this is the work. How can we calculate this work? This marker have a mass, suppose the mass is m, and the value of g we know the acceleration due to gravity small g. So work done against gravity equal to mass of the body, acceleration due to gravity, and the height to which the object is raised. We have to exert a force of mg to overcome the force of gravity and take this object up, and it reaches a height of h distance. Suppose from here to here, this is h distance, and so work done in this case is the weight of the marker into acceleration due to gravity and the height to which I had taken this up. Now what is positive, negative and zero work? When the work is done think that the force acts in a direction and in the same direction the displacement also occurs, then the work done is positive. When the displacement occurs in the opposite direction of the force, then the work done is negative. This can also be described in many other ways. When force and displacement make an acute angle with each other, then the work done is positive, and when it is 90 degree with one another, then the work done is 0. And when it makes, suppose I am exerting force in this side and the displacement occurs in this side. I don't know how, but it occurs. It can occur in many cases, although you can think of that. Think that as your homework for today. Then this thing that it occurs in this side and the displacement is in that side. So the work done is negative. And now let us see the graph, means how can we represent work graphically. Think that work equal to force into displacement. This is a graph. In x-axis we take force and in y-axis we take displacement. So what is the work done? Think that this is the graph. Then the area of this